Hello, ladies and gentlemen. Welcome back to ATA. This is Kazaula Clinton, and today I bring you an amazing tool called loan amortization for students who are doing computerized accounting and want to master loan amortization, but also for small and medium enterprises that are into money lending, but they do not have the money to actually procure a very good software. Now, I'm going to help you prepare a loan amortization schedule to actually help you disburse the loans to your clients, and then you track what they are supposed to pay on a monthly basis. So all you need is something very simple. You need a computer. This is what we need. We need a computer and also a Microsoft Excel, nothing else. These are the only tools that you need. You don't need internet, you don't need anything. Just need a computer and Microsoft Excel to do this what I'm going to do. Now, to amortize simply means to spread. So whenever a financial institution disburses a loan, they have what we call, I'm assuming that I go to a certain bank, then I acquire a loan. And the loan I'm acquiring is like 20 million. So the interest rate per annum is 24%. Then the loan period, which we call the loan tenure, is like 12 months. So if we are to compute the recoverable amount, it will be the interest payable, which will be this 24% per annum, times the 20 million, which is the loan amount. So that would give us something around 4.8 millions. Okay, so the total recoverable amount would be this 4.8, which we are going to pay as interest, then plus the loan amount, which we are calling the loan principal. So we add the two, it becomes 24.8. So at the end of this 1 year, the bank expects to recover 20 millions plus 4.8 millions as interest. So the 20 million is the principal, then the 4.8 is the interest payable. So giving us the total amount to be recovered by the institution as 24.8. So what we mean by amortization is that we have to create a schedule so that we spread this 24.8 million over a period of 12 months, which is the loan tenure. So to amortize simply means that we spread the 24.8 million, the recoverable amount, over 12 months. So you get 24.8 divided by 12. So whatever amount you get, that would be the amount to be paid by the client who has taken the loan. But that is ideal. I want to show you the practical way of doing this. And of course, you can use it in your small business. You can practice this. You don't need anything. You don't need to procure anything for as long as you have a computer and a Microsoft Excel package in your computer. So this is the question that we're going to be practicing. It is more academic, but then even practically you can apply it. You are a loans officer in Centenary Bank Mbara branch, and one of your major roles is to appraise clients and process loans for applicants who qualify and meet all the minimum requirements. A potential client has approached you and would like to borrow 40 millions for a period of 5 years. Now I want you, these statements that are highlighted, I want you to pay attention. The loan period, which is the loan tenure, is 5 years, but the bank is currently lending at an interest of 24%, but per annum, per year, on reducing balance. So your immediate supervisor, who is the credit manager, has asked you to prepare a loan amortization schedule for the client and all the paperwork so that the loan can be disbursed to the client. So let's look at what is required. What is required is that we prepare a loan amortization schedule for the client, clearly showing the total monthly payment for the loan per month, So you see, whatever that is asked, it is in per month, each month. I'm sure you're looking at that. But the information that is given is, you see, the period here is years, then here is per annum. So you must pay attention to that. That means at a certain point, we have to turn all these and put them into per month. So as for us to prepare this loan amortization schedule. So you shouldn't worry about this question. Like I always do at the end of this video, I'm going to share our WhatsApp number and also our email address. Then you're going to contact us if you need to practice. I send you questions and even more questions. So I'm going to cross to Excel and summarize this information for us. Then we prepare the loan amortization schedule. It's quite simple. So I open my Excel. Here is it's opening. Here is my Excel. So I'll summarize some of the information. One is the loan. One is the loan amount. Okay. So the loan amount, if you check from the question, loan amount is 40 million. Okay. So that is 40. 1, 2, 3, 1, 2, 3. It's 40 million. Next is loan period or loan tenure, but in years. It is in years. So the loan tenure is going to be 5 years. You put it as a figure. Don't add the years in front because we shall use this figure at a certain point as in the formula. We can change this for more visibility. Okay. Then we also have interest rate, but it is per annum. So our interest rate per annum is, we check the question, it is 24%. So you come through here and we put 24%. Now that is it. That is information that I've extracted from the question. Now, due to what is required here, everything is per month. So what we need is to turn everything that we have in the question. In what I've summarized here, I turn it into per month because the information I have is per annum. So I have to change it and I make it per month. It's very simple. So I'll first determine the loan period in month. So the loan period in month is quite simple. Every formula in Excel starts with equal signs. So you already have the loan period in years, which is 5. So I'll simply get 5 times 12 months, which are in a year. That will give me the months that are in 5 years. Each and every formula in Excel starts with equal signs. So I put equal signs. Then I click in the cell where there is 5. We do not do it manually. You simply click in the cell where you have 5. So that is B2. I multiply by 12. So the loan period in month will be 60. Hope you're following. Then I also need to change this interest rate per annum so that it becomes interest rate per month. So how do we do that? Is that I'm going to say interest. It will be interest rate per month. So that will be equal signs. I get this interest. I divide it by 12. Because if per annum it is 24%, then it means per month it is actually 24% divided by the month in a year. So that one you're done. So I'm done with summarizing everything in the question, so I can go on and I start answering the question. The first thing is that they want us to get the total monthly payment for the loan per month. That is a monthly installment, what this person is going to be paying each and every month. So that one is denoted by monthly installment, usually denoted as PMT. So the beauty with Excel is that all these formulae are already in the system. They're already configured in the system. So for you, you're just doing the input. So I will say equal signs, each and every, you must remember that each and every formula in Excel starts with equal signs. So I will say equal signs PMT. Now then when I put PMT, they show me the function is already configured inside. So when I put open brackets, they tell me what to do. They're asking me what is the rate. The rate is, I take 4 per month, it is 0.02. I put a comma. Number of period, now number of period, they mean like number of months. Like you're going to pay this loan for how many months. So the number of period is, you have to follow what they are showing you here. When I put a comma, they highlight the next item. So the next item here is number of period. So the number of period is 60. I simply click there, put a comma, you follow what is here. Asking what is the present value. The present value is 40 million, which is the loan amount. Don't put it manually. Click where the 40 is. I put a comma. What is the future value? The future value is that you want to pay the loan up to 0 balance. I put a comma. Then they're asking me the type. One is, do you want to pay the loan at the end of the period or at the beginning of the period? End of the month or beginning of the month? So in most financial institutions, they prefer that when you take a loan today, let's say today is like 6th March of 6th March 2026, then you're going to pay your first installment 6th April next month. So the type is that most of the times when you take a loan, you have to pay it at the end of the period. So we shall always choose 0 for this class. So you close brackets and press enter. So that will be our monthly installment, what you're going to be paying each and every month for the client. Now the next thing is, I'm going to now answer these two in just a single click. One is, let me check, total recoveries and at the end of the period, then total interest to be paid at the end of the period. So I'm going to determine total recoveries. Total recoveries, they mean how much they are going to recover at the end of the period. So that amount must pertain the loan amount, which we are calling the principal, which is the 40. Then also plus the interest. But then remember, the monthly installment, which we have determined here, it has a component of loan amount and also interest. So for me to determine how much this person would pay at the end of the period is simply by getting this, what he will be paying each and every month, times the number of months he's going to pay it. So I'll say equal signs. I click in the monthly installment, then I multiply by the number of period. Not manually, you click in the cell where you're referring to. So I've gotten what he will be paying, like what the bank is going to recover will be what he will be paying each and every month, which is B7, then times the loan period in month, which is 60. So I press enter. This is what we shall recover at the end of 5 years. It's quite simple like that. Then the next thing here, they want us to determine the total interest to be paid by the client at the end of the period. So we are calling that interest payable, like what the client is going to pay at the end of 5 years. So I come here and say interest payable. Now the interest that he's going to pay is actually, because first remember, in the total recoveries, there is the loan amount, which is the 40. Then also there is the interest component. So ideally, it means that if I get the 69 that you are seeing here, this 69, if I get the 69, then minus minus the 40 million, which is the loan amount. I should be able to get how much he is going to pay in terms of interest. But then when you are applying your math concept, you see these total recoveries and the monthly installment, they are already in, like this figure is already a negative, and a negative minus a negative will give you a negative. But my goal is to get 69 minus 40. So since 69 is already a negative, so I'm going to simply add the 40 there. So whatever remainder that I will get, which is around, I think it's around 29 million, it is supposed to serve as the interest payable. I'm going to repeat this. The total recovery is 69 millions, but this 69 million has both interest and loan amount. So I will take off 40 million from the 69, and the excess, which is the remainder, is going to serve as the interest payable. But if you look at the 69, it is already a negative figure. So in order for me to get an appropriate formula to give me the proper difference, is that I will simply get this negative figure, because a negative plus a positive will give us a negative. Anyway, I don't know. I know my point is home. I'm trying to say that this 69 is already a negative. So I'll simply add the 40 so that I have the excess, which is a negative. Why you see all these things are in red and negative in accounting, we mean that it is not yet payable. So if it is not yet payable, like it is a liability to us, it has to appear in brackets and in negative. So I'll say equal signs this negative figure, then plus 40. But then the ideal is that I would have gotten 69 direct if it was not a negative figure. Then I subtract the 40. I think that is okay. Now this is the interest payable per month. So after successfully obtaining that information, I can now successfully prepare the loan amortization schedule. Stay with me. I prepare for you the loan amortization schedule. So I call this loan amortization schedule. Okay, loan amortization schedule. Now this is loan amortization schedule. So here is the format. We're going to have the period, then we have the monthly payment, which is denoted by PMT. This is monthly installment denoted by PMT. Then in that monthly installment, we shall have the principal payment, which is PPMT denoted by PPMT. Then the next thing we shall have is interest payment denoted by IPMT. These acronyms are actually acceptable. Then also have the outstanding balance denoted by OS. So this is how our schedule is going to look like. Okay, this is how our schedule is going to look like. So the period we are going now to do for the next 60 months, but we shall start with month 0. Month 0 represents the date when actually the loan is acquired. So when the loan is acquired immediately, then that one we call it month 0 in loan amortization. That very date. Okay. So I'm going to create more 60 periods because the loan period is 60. So we need month. We need months from 1 up to 60. But then I'm not going to put it manually. We have to create an appropriate formula to create that. So I'll say equal signs, then I click in the formula where there is 0, the previous cell where I have 0, then I add 1. So when I add 1, it simply means that A13 represents 0, then the next will be 1. So I add 1, it will be 1. So when I autofill going down, it's going to take me up to 60. I see I've gone far, up to 77. So I come back upwards to 60. Okay, I go upwards to 60. So we have the next is PMT, we have already computed that, the monthly installment. Now, in month 0, we don't expect this person to pay. Like if you acquire a loan today, you're not going to pay it immediately, no. What you're going to do is that we go to the first month here and we show our monthly installment as this, which we have already computed. So I'll say equal signs PMT. I just click in where I had already prepared my PMT, computed my PMT. So I set, it becomes equal signs. So I will simply apply to the next 60 cells. But then you realize that our formula is inconsistent. So how to fix that? It's very simple. You edit this formula by locking it. The concept is called absolute referencing. So I'm going to apply that absolute referencing by locking the cell, so that the next time I apply it to the next cells, then it is going to be consistent all through. So if you want to notice that, I'm just going to click here where we are having our cell. This is how we lock the cell. You come and put a dollar sign just before the alphabet. Okay? Then I also put a dollar sign between the alphabet and the figure. You press enter. When you press enter and autofill again, you realize that our formula has become consistent all through up to period 60. The next thing is we determine the principal payment. Now, in this PMT, which is paid monthly, part of it relates to principal payment, which we are calling PPMT. Then another part, like part of it, will also represent interest payment. So this 1.15 that you see, it has a component of PPMT and IPMT, which we now have to separate. So I'm going to compute it. It is also generic within, like it can be auto-generated from the Excel configuration. So the formula is also simple. Equal to PPMT, I put open brackets. Not equal to PMT, we have two things. This one is equal to PMT for monthly installment. But for principal payment, it is equal to PPMT. So here they are copying for me. After putting the brackets, they're asking me what is the rate. The rate is 0.02. I put a comma. What is the period? Now the period is this actual month that we are working in. So I click there, comma. What is the number of period? The number of period is like the number of month. So it is 60. So don't confuse the two. One is period, another one is number of period. So period is this, the actual month that we are dealing with. The number of period is the 60 month that we are actually dealing with. So I put a comma. The present value is not changing. It is the loan amount, which is 40 million. I click in each cell. Future value will always be 0. Then the type will also always be 0. So I close brackets. Then I press enter. When I press enter and try to apply it to the next cells, it is also showing you that actually the formula is not consistent. So how we fix that? Again, we shall use the concept of absolute referencing. I'm going to lock all the cells except the cell for period. So the cell for period, you see, it is F14. So I'm going to lock all these other cells. Then I only leave the one for period. So how we lock is, you come here, you put a dollar sign, then in between dollar sign, I move. So I skip the one for period, I go to number of period. I also lock it. I put a dollar sign here, I put a dollar sign in between. Then there is also this one. I put a dollar sign here, I put a dollar sign here. I press enter. Now if I reapply it to the next cells, you realize that now our formula is consistent. These hashtags simply mean that our cell is small, so you simply have to expand it. So that is how you enter the formula for principal payment per month. The next thing is interest Payment, the formula is still simple, equal to IPMT. I open brackets. So when I open brackets, they're asking me what is the rate. I put in the rate, I put a comma. The period, this is the actual period that we are dealing with. So that will be 1, comma. The number of period, it will be 60. I put a comma. They're asking me what is the present value. It is still 40. I put a comma. Then what is the future value? The future value is that we are going to pay our loan up to 0. Then the type we pay at the end of the month. So I close my brackets and press enter. So when I again apply, you realize that it is still inconsistent. So we fix it. Same way, I'm going to lock all the cells, then I only leave the one for period. So I put a $sign here. I also put a $sign here. I skip this for period. I move to number of period. I put a $sign here. I put a $sign here. Then again I move. I put a $sign here. I put a $sign. Sorry, I put a $sign here. So when I press enter, then I apply, you realize that now our interest payment is consistent all through. So if you add principal payment plus interest payment for each month, it should be equivalent to the PMT that you are seeing here, the monthly installment. So the monthly installment has a component of principal and also interest. So we move. We are left with the outstanding balance. Now the outstanding balance in month 0, like that is when they acquired the loan. In the first month, on the exact date when they acquired the loan, the outstanding balance will be the total recoverable amount. So you don't have to suffer with that. Now the outstanding balance will be equal to the total recoverable amount. Then in the first month, which we are calling month 1, what will be outstanding will be this total recoverable amount, then minus what he has actually paid during that month. So it will be equal sign. This is what was supposed to be recoverable, but then at the end of this first month, the person has paid this first installment. So it is the total recoverable amount minus the first installment. So I click there and press enter. So when I press enter, I apply to other cells. Now, how to check whether you have passed or whether you have messed up and screwed up somewhere? You move down and check the future value. If you look at the outstanding balance in the 60th month, the last month, the outstanding balance is 0. So what does that communicate to you? It simply means that actually you have paid your loan up to 0 balance. Ladies and gentlemen, that is how we prepare a loan amortization schedule. So I'm going to now do some kind of formatting so that I remove these red stars and also change the amount to UGX if you are in a UGX setting. So you come here and say you come here and you highlight the space that you want to actually format. So I go to format cells, we go to number, I prefer we use accounting, change decimal places to 0, then the symbol we can use UGX. Then when I press OK, you realize that our amounts have actually become they have become black, though in brackets it simply means that the amount is still payable. So what we have done, we have just created a schedule of how a client is supposed to pay his loan. So that means you are going to be recovering this per month on a flat basis, and the outstanding balance is 0. That is okay. So you can go on and you make this beautiful, because there are some marks that you can earn for presentation. So I can add some grid lines here, you know, the borders. Then you can go to view, remove the grid lines. Then also this section, I can decide to add some borders. Then also this is the heading, can decide to underline it. Or you can also insert here and give it a heading. Say uh, loan amortization for whatever the question. Information, I can say information for client X. I can bold this. I can also give it some heading. Then I can also add, so this is just, of course there are some marks for presentation for me, but for me my point is home. If you know how to prepare the schedule, then you're good. Yes, you're good. I can also format these figures so that they match others. I format 0. I do accounting, the currency, I look for UGX, press OK. So you see they are also now fine. So I can also decide to bold this. And ladies and gentlemen, this is how my loan amortization schedule looks like. So just in a few minutes, you are able to prepare this. That is the power of having skills that you can easily monetize. So for more information, if you need the question for practice, or maybe you need personal intervention, then you're going to contact us on 077 048 0905, or you email us at aspire to a at gmail.com. So thank you. Catch you in the next time. If you think that what we're doing is valuable, then you can give us a like and subscription button, so that notification button, so that each time we drop a video, you're able to see it. Thank you. God bless you as you're practicing. Catch you next time.